Hello, welcome to this OCR Further Maths Statistics video, the second in the series looking at chi-squared tests. In this video we're going to set up a chi-squared test on a contingency table. If you recall from the first video, we were looking at how we may test whether there is an association between eye colour and hair colour. We had a sample of 131 people that we categorised in this contingency table according to hair colour and eye colour. We saw differences between this data and the expected values in the last video. We want to decide if these differences are statistically significant. We'll do this by setting up a hypothesis test. This video is going to explore further how we will test for association between those two variables. If you recall, in order to find our expected values or frequencies, we had to make the assumption that the two variables are independent. So, more formally, we're testing that the two variables are independent against the alternative hypothesis that they are not independent. And to be very precise in this case, we're trying to test whether the events hair colour, black, blonde, brown, red or other are independent of the events eye colour, blue, brown, green and other. So our null hypothesis would be expressed as no association between our two variables, which are hair colour and eye colour, or that hair colour and eye colour are independent. Remember that the null hypothesis is always the situation where there is nothing out of the ordinary, where everything is as expected, no association. And our alternative hypothesis would be that there is some association between hair colour and eye colour, or that hair colour and eye colour are not independent. Note that dependent has a subtly different meaning, so we'll stick with saying that they are not independent. As usual, before we start a hypothesis test, once we've formulated our hypotheses, we need to declare the level of significance. So, for example, we would need to state a 5% level of significance for our test. What we do, as with all hypothesis tests, is to assume that our null hypothesis is true. So we are going to assume that the two variables are independent. And that, as you saw in the last video, will enable us to construct a contingency table showing the expected values or frequencies in each category. And then we're going to carry out a test to measure how likely it is for the observed values to occur purely by chance if the two variables are indeed quite independent of each other. To do this, the chi-squared distribution is used. It's a continuous distribution and it's used for investigating whether there's an association between your two particular factors. Chi-squared is also used in other contexts, but we're just looking at a chi-squared distribution in the context of investigating whether there is an association between two factors. So we'll pick up where we left off in the last video. Here are the two contingency tables, one for the observed values and one for the expected values, calculated by assuming that the two variables are independent. For the chi-squared test to be sufficiently accurate, we need to make sure that the expected values are not too low. If they are, we need to group some categories together so that the expected value for each cell is at least 5. There are no hard and fast rules for how to do this, so you will need to use your judgment to choose categories that are okay to pool. Here you can see that the other category for eyes has 3 cells under 5. So it looks as if it would be sensible to pool this category with another, rather than, for example, pooling any of the hair categories. The sensible thing to do here would be to pool it with the next smallest category, green eyes. We just add the values in both the O and E tables when pooling, so that now the tables look like this. The new other category for eye colour is the green and other categories merged. Remember, it doesn't matter if there are observed values under 5. It's the expected values that must be at least 5. Now our tables are ready for us to do the chi-squared test. We'll see how to do this in the next video.